Hi, everyone. Welcome to chapter 14. So this chapter is all about psychedelics. We're going to talk about drugs that have typically some pretty strong effects on the mind or the conscious awareness of our perception of the world around us. Some of the examples here are things like LSD, psilocybin, things like that. A lot of, again, stronger drugs that you might think of when thinking about these psychedelic types of drugs. And we'll go into all of sort of the details of these and how they interact with our body and our mind along the way. All right, let's cover chapter 14, psychedelics. So a few things we're going to talk about here with this chapter. So we're going to go through some terminology and classification first of some of these different terms that you'll want to know and be aware of as we go through. We'll talk about what are known as indoles, a type of psychedelic medication that falls under some category or some categories that fall under this, like LSD, psilocybin, and some others. Then we'll talk about catechol, which are a different category, things like mescaline or some amphetamine derivatives as well. And so when we talk about these, again, we're mostly just going to kind of cover the general different types of psychedelics because there are so many here to talk about. And we'll give some examples as we go and talk about some of the methods of action and pharmacology of these along the way as well. All right, so let's talk about some terminology and classification first. So the first term I want you guys to sort of be aware of is this term animism, right? So this is the belief that different objects can attain certain characteristics because of spirits contained within them, right? The idea that, like the animal side of it, there being animal spirits sort of associated with different things. And this was a component of sort of early use of these, psychedelics that caused people to sort of have more, religious association and ties to the use of these. So the idea here was that if a plant contains some form of spirit, then eating the plant or consuming the plant transfers that spirit to the person who consumes it. And this was the idea for a lot of these early psychedelics, which we'll see derive from different forms of plants. We'll also talk about some different psychomimetic drugs. So these are basically drugs that, quote, mimic psychosis, right? So the idea that drugs produce some dangerous form of mental disorder. Now, they're mimicking it. It is not permanent most of the time in this case, but it is sort of a way to classify certain types of drugs. Producing hallucinations, altered sense of reality, basically a state similar to that of psychosis. Then we'll talk about psychedelics. So again, these are drugs that are altering your perceptions while still allowing the person to remain in control or in communication with the present world. So somewhat less of an actual disconnect from reality. So they provide awareness of both sort of the fantasy world as well as the real world at the same time. And these are the drugs that we tend to group according to their chemical structures, either the indoles or the catechols. So we'll talk about those. Also, the term ethogen, which is a substance that creates spiritual or religious experiences, just a term to be aware of, as well as entactogen, or a substance that enhances the feelings of empathy. And many of these drugs we're going to talk about induce feelings of both of these two things. All right, so when we're talking about the classification here and how we kind of organize these different types of psychedelic drugs, because there are quite a lot of them, and so we have to have some sort of organization to this. We kind of classify them in two different ways. First, we tend to we classify them either by their chemical structure or kind of by their effects or their properties. The two major ways that we classify them through their effects is either those that alter perceptions while allowing the user to remain in communication with the present world. So you kind of experience both sides of this. And then, of course, those that produce so much, delirium and mental confusion, sometimes even loss of memory, that you kind of are void of any sort of connection to the real world. So those are kind of the two ways we can classify drugs in this case in terms of their effects. We also can classify them based on their chemical structure, which is how we get those two categories of the indoles and the catechols, right? So indoles are drugs that basically have the same basic indole structure of the neurotransmitter serotonin. So if we think about serotonin and the effects that it has, these are drugs that kind of mimic that structure. Some examples of these are like LSD or psilocybin, come from mushrooms, that these sort of contain the structure and mimic this effect. Then we have catechols, and these are drugs that have the same basic structure of the neurotransmitter norepinephrine and dopamine. Things like this are mescaline or even MDMA or ecstasy are examples of this type of psychedelic drug. All right, so let's go through kind of each of these and talk a little bit about them. So we'll start off with LSD. So LSD actually stands for D-lysergic acid diethylamide. I know that's a mouthful, but that is why why we call it LSD. So this was actually first synthesized back in 1938 by Dr. Albert Hofmann. And so he actually synthesized this chemical and believed to understand what it would do, and actually took a large dose himself a few years later, around 1943, and noted its hallucinogenic effects. So he basically created it and tested it on himself to come to the conclusion of what LSD sort of does. And the potency of this drug sort of attracted attention from other people. So if you compare this to other drugs like mescaline, which we'll talk about here in a minute, it would require about 4,000 times more than is needed taking that amount of LSD. So pretty potent, pretty strong chemical in small amounts is LSD here. In terms of some early research on this, so often between the 1950s, 1970s, a lot of research was done on LSD, and some attempts were made to develop different models of psychosis, as well as using LSD to access our subconscious mind. So again, kind of some interesting studies that were done back in the day on how this drug might help us to sort of unlock or see parts of our brain that we aren't normally able to access. And also, because of this, it was widely used as sort of an adjunct or, a supplemental component to psychotherapy. Around 1970, the government actually stopped funding LSD research and kind of moved on from this for many different reasons. Of course, there was also many recreational uses of LSD as well. So there was research done on the recreational use of LSD, as well as just some, general use of it throughout the 1960s and 1970s. The recreational use peaked around the late 1960s. So that's why we kind of get that, we typically think of the hippie movement, if you will, that existed in the 60s and 70s. But that peak was sort of right in between those two decades. When we talk about the pharmacology of LSD or how it kind of works here, really it's usually taken orally. You can see kind of in the image, there's these little, pieces of paper, and usually the LSD is administered on the paper. It absorbs into it, and then these little strips are what's taken orally, and it kind of diffuses onto the tongue. This is absorbed through our intestinal tract, and so it's a little bit of a slower absorption process. It's metabolized in the liver, just like many of the other drugs we've talked about, and is basically excreted as a non-active version of itself. The half-life is about 3 hours, but it can have some longer lasting effects as well. In terms of tolerance tends to develop pretty quickly. So if you're using it, 3 to 4 days of daily doses, you're going to already start developing some tolerance to this drug. And there's also cross tolerance between other of these types of hallucinogens. So things like mescaline and psilocybin can have cross tolerance with LSD. There's been no demonstrated physical dependence to LSD or really to any other psychedelics to this point. So that isn't really something that comes into play with these. They don't really affect the body physically, really more just the mind. Let's see here. So in terms of the method of action specifically, we can talk about this in how it mimics our serotonin receptors, right? So the best evidence that we know of is that it's stimulating these serotonin type of receptors and kind of producing similar effects of excess serotonin in the mind. There are some beneficial uses we can talk about here. So it can have some positive subjective effects, right? Mystical experience, also sometimes ego dissolution, or the idea that you as a person don't really exist and you see the world as one sort of unified component. And, it has sort of this benefit or positive subjective effect, I guess, going on. However, of course, there are, some other things that it does. We'll call these sort of neutral effects, things like disrupting the ability to concentrate, distorting the sense of time, slowed thinking. These I would say are neutral, leaning on the side of negative, but could be used in certain circumstances for their benefits. Again, other research has been done on this, looking at things like the treatment of alcohol disorders, or reducing even cluster headaches, which it has shown some potential benefit towards. In terms of the adverse reactions of the negative side effects, the main one that tends to be brought up and talked about are what's called flashbacks, right? Which is the idea of basically people in a non-drug state, so haven't consumed the drug, re-experience one or more of the perceptual alterations of the drug when they were taking it. So they're basically sober at the time, but then sort of have these flashbacks of feelings of when they had consumed the drug. Now, this tends to be pretty rare, but is something that has been documented and could be seen as a potential adverse reaction. All right, the next drug to talk about here is psilocybin. So this is the psychedelic component that comes from mushrooms or magic mushrooms, right? So this is the idea of this chemical that is found and is produced naturally through different forms of mushrooms that grow, in the wild. There's been research done on this, looking at the effects of psilocybin. Especially more recently, they've looked at things like microdosing, taking small amounts of the drug, and how it can have some positive effects. Most of what has been seen with this tends to be used for treating things like depression or other negative psychological components. And a lot of the research here has shown some positive effects, especially when taken in small amounts. In terms of the acute effects or the short-term effects of this drug, we tend to see that you get changes in mood, perception, and thought. Most of the time, the experience tends to be pleasurable, enriching, or even euphoric. But sometimes you can see some negative effects as well. Some negative mood effects, as well as headaches or feelings of anxiety or things like that. So there are definitely positives and negatives to this as well. In terms of the chronic effects or long-term use, relatively little is actually known. Most studies haven't really looked at the long-term effects of this. One study indicated that no subsequent drug use persisted when looking at sort of long-term impairment of participants that took specifically psilocybin for long periods of time. I think that, like I said, there's very little research actually looking at this, so I would take that with a grain of salt. I think there is certainly the potential for long-term negative side effects with this as well. All right, let's talk about a few other of the indole classification of hallucinogens. We have some examples like morning glories. These are a form of flower that produce a chemical that has other forms of hallucinogens under the indole category. We have Hawaii baby woodruss, another flower, similar thing. Let me see if I can get this one out. Dimethyltryptamine, or DMT. You may have heard of this before. This is actually a chemical that is produced in our brain often when we dream, and can produce sort of those dreamlike states, but it also can be synthesized and taken as a hallucinogen as well. Ayahuasca, which is another form of plant that is oftentimes distilled down into a tea or some other form like that. And then, of course, other tryptamines that kind of fall into this category as well. There's quite a few, but you can see most of these tend to be derived from some kind of naturally occurring plant or something in the world. All right, so those are the indole categories. Remember, those structures that tend to mimic the serotonin neurotransmitter. On the other side of things, we have the mescaline forms, which are those that kind of mimic the dopamine receptor here, right? So our first example here is peyote, which is, again, derived from a cactus. It's a carrot-shaped cactus, what we see in the picture here, small, spineless. And it actually has more than 30 different psychoactive compounds inside this peyote cactus. But once it's sort of synthesized down, it can create sort of a drink or a tea that people take for different reasons that produce similar effects of the other hallucinogens, vivid colors, and other visual effects as well. When we talk about this, we can also talk about some different cultural use that has been used, or that mescaline has been used for in the past. Actually, the Native American Church incorporates peyote into its ceremonies. So it's definitely a traditional practice of different Native American cultures. And that has brought with it some different legal issues, right? So in 1990, the Supreme Court actually ruled that the state of Oregon could prosecute its citizens for using peyote. So part of the problem there is that, of course, there's going to be Native American tribes sort of in that region. And then back a few years later in 1994, Congress passed a law saying that no Indian shall be penalized for using peyote. So for legitimate traditional purposes. So kind of, overruled that 1990, at least for people of Native American descent using it for traditional purposes. So again, there has definitely been some sort of legal, dispute back and forth on this and how it can be used for those cultural and traditional uses while still keeping it under control, sort of from a FDA perspective. When we talk about the pharmacology of this form of hallucinogen, typically it's ingested orally, similar to the other ones, which means a longer metabolism, right? It takes a little bit longer to go through that digestive tract and to be absorbed into the body. This actually has a longer half-life than something like LSD when we were talking about this, with a half-life of closer to about 6 hours. So it's going to have a much longer sort of effect here. Remember, half-life is not the amount of time it's going to last. It's the amount of time that it takes for half of it to be broken down in the body. In terms of tolerance and psychological and behavioral effects, we can talk about sort of, in low doses, it tends to produce primarily euphoric feelings, and in higher doses can actually give rise to full-on, hallucinations in this case. Tolerance tends to develop more slowly to mescaline than to LSD, but there is some cross tolerance there as well. When we talk about building up tolerance to one, like LSD, can produce tolerance for the other form here as well. All right, so that kind of covers the mescaline category. So let's talk about also some amphetamine derivatives in the form of psychedelics. So we're kind of now shifting gears a little bit here when talking about this. So a large group actually of synthetic psychedelics is chemically related to amphetamines. So we talked about amphetamines before, and some of these psychedelics that are produced or synthesized have some chemical similarities to them, the amphetamines. So we can see similar effects when we talk about these. Some examples of these are things like MDMA or ecstasy, right? So this particular substance, psychiatrists thought originally might have some therapeutic aid, but more recently, it's shown some more negative effects. In large doses, it can actually destroy different serotonin neurons, which can produce long-term negative effects. It takes a lot of time to kind of get those back. We also have MDA, which is a little bit different, produces effects very similar to MDMA, but is a different chemical structure. We also have dimethyloxymethylamphetamine, or DOM, which is, again, another chemical structure similar in these. Oftentimes can produce feelings of serenity, tranquility, or peace, but has some of those same negative side effects as well. It's pretty potent. It's 100 times more potent as mescaline and about 1/13 as potent as LSD. So sitting somewhere kind of in the middle there. But again, has more of these, amphetamine derivative effects. Then we have NMDA antagonists. So these are things that sort of work slightly differently. So an example here is something like PCP or angel dust, right? So this is technically a medically safe, but psychologically troublesome anesthetic for people. So these are drugs that medically may not produce any negative physiological effects, but certainly psychologically can produce profound and often harmful psychological effects. So again, we have examples like PCP or angel dust. These tend to be, things that come from so it was called angel dust actually because it tended to be sprinkled onto things and oftentimes sold as marijuana in the 1970s. It would be sprinkled on like parsley or oregano. People would say, "Oh, it's marijuana," but it was actually just those herbs covered in PCP. And this is interesting too. It has a similar mechanism of action to NMDA. By actually affecting the glutamate receptor. So some effects here of PCP can be quite severe, but work slightly differently than some of these other drugs. Then we have ketamine. So this is another antagonist. Again, it works to kind of lessen those effects. It's less effective or it's less selective than PCP, but still has quite a strong effect. It also has been used sometimes to treat major depressive disorders and also produce sort of antidepressive effects in smaller doses. In larger doses, it can actually have effects that induce sort of complete loss of self. You may have heard of the term K-hole. This is the idea of basically falling into a psychological black hole of perception and awareness. And then, of course, we have some other examples here like memantine and deoxythropin, other examples, again, of these antagonists that work sort of to block sort of the effect of NMDA. All right, so again, these are derivatives of amphetamines. And so let me show you real quick. We'll go back, we'll jump over to mouse party here. And let's take a look at our ecstasy mouse. Is that what we've got? LSD, we'll come back to that. Let's take a look at our ecstasy mouse and throw him in the chair and take a look at kind of how this works as well for him. So what we can see for ecstasy is we see normally what's happening here is this effect of our normal production, normal effect of these neurotransmitters. In this case, we're looking at serotonin neurotransmitters where we see their transporters bringing them back up and the receptors existing sort of in their natural state. What happens is when ecstasy gets introduced into this, it kind of mimics those serotonin receptors and gets absorbed into that axon terminal. So what's happening is that thinks there's a lot of extra serotonin. And so these serotonin transporters kind of get confused. And rather than absorbing the serotonin out of the synaptic cleft to kind of recycle it back into the mix, it starts pumping them out, right, into the cleft so that they're more readily available to be bound to those receptors on the receiving or that bottom receiving neuron. And so they're more often and going to continue to bind over and over again to those receptors. So again, it produced the effect of having more serotonin available in the system. And you see that increased effect of that serotonin on that receiving neuron. And again, what's important here is how this kind of affects certain regions of the brain. And we can see here that this affects, again, a pretty wide range of the brain, especially areas related to mood, perception, as well as sleep and appetite as well. But it acts on these reward pathways and just kind of simulates the extra level of these more positive neurotransmitters like serotonin in this case. All right, let's eject him and we will kind of move on from here. I guess we did skip over LSD. We'll throw the LSD mouse in here right now and take a look at him as well while we're here. And then we'll come back to the last one for our last use case. So let's look at LSD. So when we're talking about LSD, we see this coming in and binding to these serotonin receptors. Remember, LSD mimics serotonin in this case by actually binding to those receptors. It's so close to it, it can bind to the receptors. And what happens is based on the type of receptor, it's going to do different things, but we still see it affecting sort of this synaptic cleft, the synaptic transmission in different regions of the brain, which again produce different effects, sometimes blocking, sometimes exciting, which is why we get sort of that wild effect of LSD on the brain. It kind of has somewhat unpredictable effects when we look at this. And again, this happens on different pathways, different regions of the brain associated with different things. So in this case, looking at oftentimes sensory areas and connection points, pathways of connection within the brain. All right, and that wraps up chapter 14. So I hope you guys have a great rest of your week. Next week, we're going to get into chapter 15, which is all focused on cannabis. You may have noticed that missing a little bit from this chapter. You might associate it with the psychedelic category, but there's a lot to go over with cannabis specifically. So we're going to focus that as its own chapter next week and kind of go into a lot of the history, the details, as well as the pharmacology and medical side of things as well.